Hi there, welcome back to Through Inquisitive Kids. So far in Chapter 9, we've learned all about inequalities and how to apply them in word problems. Now in this lesson, we're going to be comparing one variable inequalities with linear functions and how we can use them both simultaneously in word problems to help us solve. Find the connections between inequalities and functions. This is part 1 of our lesson, Inequalities in Word Problems. And part 2 will be posted soon, so if you would like to be notified for that, please don't forget to click that subscribe button. Anyways, let's get into the lesson. So the learning goals of today is to experience the connections between linear inequalities in one variable and linear functions, and to also use the relationship between inequalities and functions to solve simple word problems. So let's do some review for our introduction. Solve the inequality 2x minus 5 is greater than 0. So this is pretty easy. Using the properties of inequalities, we can first add 5 to both sides of the inequality and then divide both sides by 2. So our answer for that would be x is greater than 5 halves. 2. The graph of a linear function is blank. Its x-intercept is blank and its y-intercept is blank. So here you're just going to describe what the graph of a linear function looks like and write down the coordinates for the x-intercept and y-intercept based off of when the linear function can be represented as y is equal to kx plus b. Alright, so the graph of a linear function is always a straight line, and its x-intercept is negative b over a comma 0. So this a right here is just in the place of k, so that also works. It doesn't really matter which variable that you use. And its y-intercept would be 0 comma b. When graphing a function, blank points are needed. So how many points do you need to know before graphing a function? And a hint is that you know already that the graph of a linear function is a straight line. Well, remember, 2 points determine a line. So our answer for this blank would be 2. And 3. Linear function y is equal to 2x minus 5 intersects the x-axis at blank and intersects the y-axis at blank. Again, for these two blanks, you're going to fill it in with coordinate pairs. So here we're going to have 5 halves, comma 0, and 0, comma negative 5. Next, let's discuss the relationship between unary linear inequalities and linear functions. Unary inequalities and linear functions. Graph linear function y is equal to 2x minus 5 on the Cartesian coordinate system. Well, that'll look like this. Here we have the coordinate plane, and out of this table, we have a table that tells us input x and its corresponding output y. So if x is equal to 0, y is equal to negative 5. If x is equal to 2.5, then y is equal to 0. So here we have the coordinates of our x-intercept and our y-intercept. Now since we only need 2 points to graph a function, these are the 2 points that we'll use. First we have 0, comma negative 5, and then we have 2.5, comma 0. After connecting them, we have the graph of the function y is equal to 2x minus 5. So right now we're just refreshing some skills from linear functions. Let's observe this graph and then answer the following questions. What value does x have to equal in order to make 2x minus 5 equal to 0? So let's analyze. Another way to say this same question is to say it as, what value does x equal to make y is equal to 0? Because remember, y is equal to 2x minus 5. Y is equal to 2x minus 5, which means that we can replace this part with y. So essentially we're being asked, what value does x equal when y is equal to 0? What point is x equal to 0? Well, it's this point right here. On the graph, when y is equal to 0, otherwise known as this graph's x-intercept. We have when x is equal to 2.5, 2x minus 5 is equal to 0. Now let's answer another question. What value does x equal to make 2x minus 5 greater than 0? Notice how now it's not an equal sign, but it is an inequality. But we have the graph right next to us, and we could just simply look and use our common sense and knowledge of the coordinate plane. So we have our graph here, and we know that y is equal to 2x minus 5, which means that we can replace this as y is greater than 0. What value does x have to equal to make y greater than 0? Well, let's look at all of the parts on this function where y is greater than 0. That's everything starting from here going up. And notice, when I circled this point right here, I circled it instead of filling it in. Filling it in would be greater or equal to, but this is just greater than, so I'm just going to circle that point. So all of the values up here fit the requirements. Therefore, since we know that this point right here for x is 2.5, we can answer with when x is greater than 2.5, y is greater than 0. So again, we can analyze this as y is greater than 0. So this entire section right here. That point is 2.5 comma 0. So when x is greater than 2.5, 2x minus 5 is greater than 0. Here's a third question. What value does x have to equal to make 2x minus 5 less than 0? Well, it's the same thing if you think about it. 2x minus 5 is equal to y. So it's the same thing as what value does x equal to make y less than 0? All you're doing is looking in the opposite direction. So this is all of the values when y is less than 0, and this is it represented on the function. And since the point right here is still 2.5 comma 0, our answer would be when x is less than 2.5, 2x minus 5 is less than 0. Our fourth question here. What value does x equal to make 2x minus 5 greater than 3? So now it's a bit different. Previously we were asked 0, but now we're just increasing our right side of the inequality by 3. So let's analyze this step by step. This is the same thing as what value does x equal when y is greater than 3? This is all of the values when y is greater than 3, and this is it represented on the graph. So everything from this point and onwards. And we see that the coordinate of this point right here is 4 comma 3. So we can answer with when x is greater than 4, 2x minus 5 is greater than 3. Do you see how our knowledge of inequalities can really help us with solving problems related to linear functions? So here's our summary. Throughout our analysis and observations of the graphs of linear functions, we can use graphs of functions to solve inequalities, and we can also use solving inequalities to help study functions. Inequalities and functions are closely related. If y is equal to negative 2x minus 5, what value does x must equal to make y greater than 0? Well, there's two methods that we can use to solve this. Use the graph of the function to solve the inequality. First, we draw a graph of y is equal to negative 2x minus 5. So here is our graph, and that is our x-intercept right there, negative 2.5 comma 0. And now answering the question, what value does x equal to make y greater than 0? Well, all of the points where y is greater than 0 shown on this function right here is everything from this dot and onwards. From the graph, we can see that when x is less than negative 2.5, y is greater than 0. So that's one way to do it. But the second method is to transform function problems into inequality problems. So instead of thinking this as a function problem, we can think of it as an inequality problem. That is, we can solve the inequality negative 2x minus 5 is greater than 0. Here what we're doing is, well, you want us to solve for x when y is greater than 0. But since previously we know that y is already equal to negative 2x minus 5, we can just replace this y right here with the expression negative 2x minus 5. So now we have the new inequality, negative 2x minus 5 is greater than 0. After solving, we see that x is less than negative 2.5 and y is greater than 0. So comment down below which method do you think is more efficient or works better for you. Personally, for me, I like method 2 better because I think it's just quicker and more straightforward when you solve it. I do understand how drawing out a graph and everything for maybe a beginner can really show what each value in here really represents, and I get that. It's just that every single time when you're solving a problem like this, it's kind of inefficient to have to draw out an entire plane and then graph everything. So personally, I prefer method 2. But again, tell us what you guys think and which method do you think works better for you. Now we're gonna use all of the information and concepts we've just learned to solve a word problem. Two brothers are racing. The older brother lets the younger brother run 9 meters first and then he starts to run. It is known that the younger brother can run at 3 meters per second and the older brother can run 4 meters per second. List the quantitative relationships, make a graph of the function, and answer the following questions by observing your graph. And so these are the 3 questions we have to answer. 1. Until what time was the younger brother ahead of the older brother? 2. What time did the older brother get ahead of the younger brother? 3. Who runs across the 20-meter mark first? And what about the 100-meter mark? So that was a long paragraph, and we're going to break it down and analyze it one by one. So here is the first step of our solution. And we're just setting the variables here. Let the time taken by the elder brother to start running is x seconds. The distance that the elder brother has run is y1 meters, and the distance that the younger brother has run is y2 meters. The relationship with each brother's distance run and the time spent running would be y1 is equal to 4x, and y2 is equal to 3x plus 9. Here, we're just using the basic itinerary problem formula, which is distance is equal to speed times time. And see how here we've given each brother a y value and an x value? Well, this will help us when we have to draw a graph later on. So just to explain a bit more, y1 is equal to 4x. So that represents the distance that the elder brother has run because x only represents the time when both brothers are racing. Remember how it says the older brother gives the younger brother a head start? So this is a head start that the older brother is giving his younger brother. But the x value only represents the time when both brothers are running together. Okay? And here, 3 again and 4 are their speeds. And for y2, that is the distance run by the younger brother. So he would be y2 is equal to 3x plus the 9-meter head start he was given first. This is our graph that we can use to make out of the quantitative relationships from the variables and the word problem. Here we have y1 is equal to 4x, which is the function for the elder brother, and the younger brother's function is y2 is equal to 3x plus 9. Let's break it down, the thinking down, into 3 questions that we ask ourselves. When blank, the younger brother is ahead of the older brother. Well, let's look at this graph. Mathematically, this is when blank is the y value of the blue line greater than the y value of the red line. So again, this is the graph method. And this intersection point right here has coordinates of 9, 36. When x is greater than 0 and less than 9 seconds. And also this intersection right here, this represents? Well, this represents the time when the older brother catches up to the younger brother. So now let's do the second question. When blank, the older brother is ahead of the younger brother. Well, that would be when x is greater than 9 seconds, because past this intersection point right here, the older brother is leading ahead of the younger brother. The blank brother runs across the 20-meter mark first. The blank brother runs across the 100-meter mark first. Again, we can look at this graph. The first one is asking for the 20-meter mark. The 20-meter mark would be between 18 and 24. And this is approximately where it's talking about. And we see that at the 20-meter mark, the blue line y coordinate is still bigger than the y coordinate of the red line. So the younger brother was ahead at that moment. But afterwards, the older brother catches up, and the older brother runs across the 100-meter mark first. So that was our graph method. What about the algebraic method? Well, here are the functions for each of the brothers. Now we are going to answer the same 3 questions. Until what time was the younger brother ahead of the older brother? How we can express this is by using the distance of the older brother, which is 4x, less than the distance run by the younger brother, which is 3x plus 9. Simplified, we have x is less than 9. So it would be before the 9th second mark. What time did the older brother get ahead of the younger brother? Well, that would be when 4x is greater than 3x plus 9. And solved, x is greater than 9. So past the 9-second mark, the older brother was ahead of the younger brother. And finally, who runs across the 20-meter mark first, and what about the 100-meter mark? Well, 4x is equal to 20, which means that x is equal to 5. 3x plus 9 is equal to 20, and x is equal to 11 divided by 3. Now, 4x is equal to 100, and x is in turn equal to 25. But for the younger brother, 3x plus 9 is equal to 100, and x is equal to 91 divided by 3. In this case, the older brother crosses the 100-meter mark first. So, comparing the geometric method and the algebraic method here, when we first used the graph, which was what made it more geometric, and we used the graph to answer a lot of our questions. But in algebra, a lot of the things we did was convert the words into equations or expressions and then substituting and then solving. So I'd say if you're more of a number cruncher, you will work better with algebra, but if you are more of a visual learner, you could use the graphing method better. Alright, so here's example 2, and I promise this will be the last problem in this video. From the graphs of the following functions, write the solution set of the following inequalities. Well, let's just do this together. So 3x plus 6 is greater than 0. Here, we can see that x is greater than negative 2. This is just enhancing some skills we've already worked on. 2. 3x plus 6 is less than or equal to 0, which is when y is less than or equal to 0. Well, that would be when x is less than or equal to negative 2. And, this point, this x-intercept right here, the point where it's negative 2 comma 0, that is kind of the turning point for when y is greater than 0 or when y is less than 0. So finding the coordinates of that intersection point right there is very crucial to solving the rest of these problems. Now for 3 and 4. Negative 3 plus 3 is greater than or equal to 0. So here on the graph, we can clearly see that it's x is less than or equal to 3. And the final one, negative x plus 3 is less than 0. We see that that's when x is greater than 3. So here is our summary. From a numerical point of view, finding a solution set of ax plus b is greater than 0 or less than 0, where a and b are constants and a is less than and a is not equal to 0. This is the same as the value range of x when the function value of a is equal to ax plus b is greater than or less than 0. Now from a geometric point of view, finding the solution set of this inequality, where a and b are constants and a does not equal 0, from a geometric point of view, this is the same as the value range of the independent variable when line y is equal to x plus b is above or below the x-axis. So doing the same thing, trying to find the same thing, depending on which point of view you look at it from, it means it corresponds to something else. For example, here it is finding the value range of x looking at the function value. But from a geometric point of view, it's the value range of the independent variable when looking at the function, the graph of the function compared to the x-axis, whether it's above or below. Class summary. Today we learned all about unary linear inequalities and linear functions. When we start with a linear inequality and we transform it into a linear function, by doing this, it is possible to study the graph trend of a linear function. And when we turn linear functions into unary linear inequalities, we see that inequalities can be solved directly through graphs of linear functions. Here are the 2 skills we learned today. Experience the connections between linear inequalities in one variable and linear functions. Use the relationship between inequalities and functions to solve simple word problems. Again, part 2 of this lesson will be coming out, so if you would like to be notified for that, please click the subscribe button as well as the notification bell. Again, thank you so much for watching 3 Inquisitive Kids, and we'll see you next time.